Suppose 500 is deposited at the end of each month into an account that offers a 6.25% annual interest rate compounded monthly for 30 years. And part A is how much is the account after that time. Part B, how much was invested. And part C, how much interest was earned. We're getting into multi-step problems now. So if part A is bad, there goes B and C. All right, so part A, the reason this is a future value problem is because the interest is being compounded and how many times is stocking away money? Once or more than once? More than once, because you're putting a payment at the end of each month. So more than once. So that says periodically, we're building up the account, so it's a future value. So part A, we're going to say FV equals, what is the payment? 500 times the fraction, 1 plus, what is our I here? Over 12 raised to the N. Remember, N is the number of payment periods total. 12 times 30. Minus 1. All over another I, 0.0625 over 12. Again, we do not discuss where this comes from. Don't ask me about my business. But it comes from a college algebra, geometric sequences. We're not going to talk about it. Now, that's the setup. The other beast is putting it in the calculator. For the problems, for the formulas in this section and the next section, when you have these crazy, crazy fractions, you have to put an extra set of parentheses around the numerator and an extra set of parentheses around the denominator when you write it into your calculator. So reading from left to right, top to bottom, in your calculator, you're going to write, you know what, I'll put it over here. You're going to write 500. First parenthesis to say it's the numerator. Second parentheses for this quantity. 1 plus 0.0625 divided by 12. Parenthesis for that quantity raised to the, what is 12 times 30? 360 minus 1, parenthesis to finish off that numerator. Now we do the divided by. And now what do I need? Parenthesis to start the denominator. 0.0625 divided by 12, and a parenthesis to finish the denominator. So that is how you would type it into your calculator. So again, parenthesis for the numerator, set of parentheses for the denominator. What'd you get?
$526,959.90.
959?
959.97.
So that was garbage?
Wait, $500 a month in the next 30 years and retire with $500,000?
Ah, are you going to take out all $500,000 at once? I wouldn't. You'd pay yourself monthly. So when we hit the next section, what's going to happen is you're going to start taking periodic payments to yourself, but then the rest still stays in there and still earn interest. So we're going to see that you will be able to hit $1 million. You will be able to take out $1 million. No, not really. It won't take 50. Part B, how much was invested? Well, how much should we put away each month?
500.
So we did 500 a month for 30 years. So notice, part B is not I equals PRT. So don't see the word interest and think I equals PRT. No. What do we get here? Is that 180? So we put away $500 a month for 30 years. We put away $180,000. We ended up with $526,959.97. So part C, how do we figure out how much interest was earned? Subtract. So what is 526,959.97 minus 180 large? Did I say that right? I don't watch cop shows. Anyone? $346,959.97. Good. And I'll be honest with you, even though our economy is not doing great right now, over any 30-year period that you pick, even with the highs and the lows, the average is around 6.6%. So this is a perfectly reasonable problem. The trick is the 30 years. So as soon as you get your careers going and you're able to put away money into a retirement account, put money away into a retirement account. Because otherwise, did we discuss about this in this class? People are living longer now. So what are your parents doing with your inheritance? They're spending it. So people are getting less inheritance because people are living longer. So be nice to mom and dad for the right reasons. But in the meantime, save up for yourself. All right, we're going to do this problem again, but instead of depositing monthly, we're going to deposit annually. And it's actually the same amount as we'll see in part B. So we're going to figure out which one's better, to put away $500 monthly or $6,000 annually, which is the same total amount invested. Okay? So if you would write that down, and we'll go through it. So what's the setup for part A?
Everything's the same except it's still 1265.
So can you tell me what it is?
1 plus.
Well, what's the?
I'm sorry, 500 times.
No. What's our new payment? 6,000. So instead of doing 500 monthly, we're doing 6,000 annually.
Right.
So yeah, so 6,000.
1 plus 0.065 raised to 30.
Right. So I'm filling it in completely, but what you're saying is correct. Since we're only multiplying by 1 and dividing by 1, this one right here, oh my gosh, and that one right there aren't necessary. I'm just putting them in for the sake of the problem. All over, and actually I need another highlighter here. This one right here we don't need, because we're just dividing by 1. However, don't get lazy. That's only going to be for annually, where it doesn't matter. Boop. So what does it look like in the calculator? I'll start you off, 6,000.
Parentheses.
Yep.
1 plus.
Yep, so again, we don't need to write divided by 1.
Share 30 minus 1.
Yeah.
Parentheses.
Yeah.
Divided by.
Sure.
Parentheses.
Uh-huh.
0.0625. Parentheses.
Yep. So again, we're not writing the dividing and timesing by 1. So if you would throw that into your calculator. Carefully. I got 495,751.54. Good? So part B, how much was invested? Well, we put $6,000 away per year for 30 years. So as stated, this is still $180,000. So we put away the same amount of money. However, in the previous problem, we made well into the $300,000 in interest. But how about for this one? What'd you get?
315,751.54.
So for this problem, for this amount of money, $180,000, which is better? The first option, because let me go back real quick. We made $30,000, $31,000 more in interest. And we put away the same amount of money. Now that's a problem-to-problem scenario. You can't just assume that if you the higher you compound, you're guaranteed more money. And you have to worry about how many years it goes for, things like that.